Okay, hey, it's recording now. Perfect. This is official. Oh fuck. What is this? Uh,
We had to cut that out.
oh shit, our homepage popped up. That was not intentional. Okay, so we're gonna discuss upgrading contracts. So first thing, should I talk about theory or should I just go into code? Let's just talk about a little theory.
Yeah, a little theory. It's fine.
Okay, a little theory. I've heard. We're using Open Zeppelin. Um, actually, normally when you write let me see if I can this screen here. Okay, so normally when you're writing code, let's say you write a code called box that gets deployed at address 0x1234, and at this address, if you check its code, we will have some kind of implementation code, and it also has state. So state is like the storage in the blockchain.
Sure.
And then if you want to change the implementation code, let's say the state has some variable called counter, and there's a method called increment, and this thing is right now doing counter. Let's say you want to change this logic from +1 to +5, you will basically change the logic, right? And you will redeploy that code and you will get a new address.
Sure. Yeah.
And that's not okay because we want to work in an iterative fashion. We want to change this code. So that's why we want to use upgradability. And there are many patterns and ways to do that. Let me tell you about what I was doing before. So what I was doing before was like a poor man's version of this. I would set up a proxy. So I would deploy like one contract called box, and then inside, and then let's say I have another contract called box helpers, which has like the increment method in it.
Sure.
This would be deployed to like here, and then this would be deployed here. And then in this guy, I would have a library for box helpers. So it would be like, sorry, not library, interface for box helpers. So here I would say
And then you're passing the address and
address of
the address.
this guy, correct. And now like whenever I wanted to like change this, I would deploy box helpers again. This would come give you a new address, and I would just go here and update this. And like think like there was a function over here called like update
Box helper address.
box address.
Yeah.
And address like that. And this would be like obviously only owner or something.
Yeah.
That's kind of like what I did in the last project. This kind of like works, but you kind of have to like think about all the implementation and helpers, what they could be. You have to keep them separate, and you can really update that fine with this kind of approach. But what if you want to add like this obviously has a counter here, right? But let's say I wanted to add another variable called like ratio.
Yeah.
Like now you can't do this, but maybe you can write another one. This guy and this guy has this thing in it. But let's say we want to introduce a brand new function like get my face, but you can't add this function now in this contract. You can only so you're very limited, but it works. This is like the old way of how I was doing it. This is not truly upgradable, but it's like I would say a hack around doing it. And some people have recommended to me even now that, hey, you should just continue doing this because this works and this is stable and it doesn't have all the pitfalls of upgradability.
Yeah. So you gotta have the skeleton structure, right? Like you gotta know all the functions and maybe all the.
But you don't know that. Who the fuck knows all those things in advance? That's the whole point of iteration. But like, okay, sure, you know it. But what happens when you don't know it? Now you're fucked. You just
you're
like
fucked,
business, you're out of business. You can't fix your token because your token has an address and different AMMs are using it and DEXs are using it. And you're like, nope, new address, guys, everybody go there. Like,
Yeah, that's called the EAT method. People call it EAT.
eat.
Yeah, YEET, like EAT, like you eat your old contract out, and then you have a new contract. Everyone move your money there.
So we did that with NFT deals when we were doing like a new auction and moved all the data over. But that's a lot of work, and you have to like manage all of that, and the events are here. So I said, I want to invest some time into learning how to do upgradability properly. Okay,
Gotcha.
so that was one theory. Let's delete this. So can I give you a little bit more theory on types of proxies, or do you want to just go to like?
No, let's do types of proxies.
Okay, so one is like you have one contract called proxy.
Yes.
Then there is another contract called implementation. And then this is, and the proxy has the implementation address, and then it has a delegate function. Sorry, not delegate function, come on, fallback function. So if you call the proxy, if it doesn't know it, it will call the fallback, and in the fallback, it will call the implementation contract.
And the implementation address keeps changing. That's why it's you fall back to multiple.
Yeah, and then you have like a function here, it's called change
implementation
address, right? And like only one guy can change it.
Yeah.
So this fallback code is like some special low-level assembly code, because the regular delegate doesn't have like, doesn't take it can like call it, but it can't get the response back. So anyways, there's some like special assembly code you can copy paste here, so into your fallback. But this pattern has had security vulnerabilities. The basic problem is that this this function change implementation address can have a functional clash with another function, which could be in the implementation contract. So then when you call it, whose is it calling? And then you can have some kind of issues.
Can you explain the functional crash? Yeah.
So you know what a function selector is? So what? Okay. In Solidity, on a contract, when we call a function, we're calling the function selector, and the function selector is the catcheck of the function, but only first 4 bytes. So think of it like this: KE is catcheck 56 of change imp address. Hey, we can actually run this. Okay, let's go here. By the way, all of this is not, we haven't actually entered proxies. This is all time being wasted. But
no, this is good.
Okay, that's not a function. Oh, that's not a function?
Sure, catcheck to 56.
Well, it's obviously not working. Oh, what's going on? No, I don't want that. Yeah, it is a function. So why is it not working? Here.
You have a version of Solidity, maybe?
Oh, it's working. I thought it wasn't working before. Anyways. Okay, so like if you were running this function, change blah.
Does it take all the parameters too, or it's just the name?
Yeah. You have a full signature, but I'm trying to make a point here.
Yeah.
You're basically, then you're gonna just take the first 4. So I don't know how to do first 4, but like a small portion of the first 4 bytes, so maybe like
and that's the selection, right?
right? So you can imagine that there can be another function whose first 4 bytes match with this function.
Yeah.
So a hacker could like very quickly come up with another function which has a different name, but the same first 4 bytes. Because it's not looking at all the bytes, it's only looking at first 4 bytes, it's possible that that can happen.
Okay.
So if you have that, then your implementation has another function called say hello, but say hello has the same 4 bytes as change implementation address. So that can lead to some issues. Okay.
Okay.
To solve this, Open Zeppelin has something called transparent proxy, where they've addressed this issue. But now what happens is that this has higher overhead, and so it's more gas every time you run a call, and you have to maintain another. There's like 3 contracts deployed. Anyways, we're not using this. I'm going to spare you from knowing about this. So
All right.
we're going to use something called UUPS proxy.
Yeah.
This I think stands for Universal Upgradable Proxy Standard. Okay,
Yeah.
that must be it. And this has the same concept like this, but what we do is that this implementation address obviously stays here. This code, the code to change the address lives inside the implementation contract. So when you call it, change implementation address, it's always going to be here. It's never going to be in the proxy. The proxy doesn't have it at all. So that's what the UUPS is. So the downside here is that you must have this function in every implementation, or if you upgrade to an implementation which doesn't have this function, you've bricked your proxy because now you can't upgrade.
So yeah, you're forcing it to have it there, then there cannot be no clash. That's the idea.
That's the idea.
But then how are you changing what proxy points to through this contract?
What proxy points to implementation contract?
Yeah. So
Yeah,
how are you
the
changing
address is still here. This
Oh,
address,
okay, yeah. And then you have 0, 1, 3, 2, 4, and you are
yeah, this is 0x1 2 1 3 2 4.
wait. So
This is a proxy contract.
yes. So how is the implementation address is changed on the proxy contract to another contract?
So I will do something like proxy dot change imp address.
I see, yeah, because you have the proxy's address, that's constant.
Yeah, the proxy address remains constant, never changes. That's the whole point of upgradability. So I call change implementation address. Proxy delegates to the actual implementation. The implementation says, okay, let me change it. And like this guy will say, okay, imp address equal to whatever you passed him.
It was very circular.
Yeah.
So this calls that, which calls this.
Anyways, I'm just telling you theory. All of this we don't have to do because the framework does it for us.
Sure.
But yeah, in high level, you will always call the proxy. The proxy only has memory, only has data.
Yeah.
All the implementation is in the implementation. So
Sure.
now your implementation needs to have code to change the address of the next implementation. If it doesn't have it, you bricked it. That's the only downside of the UUPS style. Other than that, it's
have to change implementation address function. You have to have it. That's
yeah. And the framework will make sure you have it, and it will raise an error if you don't have it. So all that is taken care of. But we were just talking about proxy, so I brought it up.
Yeah.
Okay. So let's look at Open Zeppelin. Here. Great. So they have made this plugin which you can install. And with this plugin, we get 2 new methods. one called deploy proxy and one called upgrade proxy. So deploy proxy, when you call it, it basically deploys the proxy and the implementation code, and it connects them. And then next time when you want to upgrade the code, you just call upgrade proxy. You pass in the proxy address, which is the original address of the proxy, and then you pass in code for new implementation. And what it will do is it will deploy the new implementation code and connect them. And before it actually deploys and connects, it will do all kind of checks to make sure that the stuff you are pushing is actually good. So you're not going to break it. Okay. So should we do like coding? Coding? Okay. Sounds good. What should we call it?
You're making a new hard hat thing.
Yeah, but we're gonna call it the project. That's the naming is the hardest thing. We're stuck.
UUPS upgrade test.
UUPS upgrade
Demo.
Yeah. Okay. Okay, hard hat. How do you get started? Click on get started. Yeah. Oh wait, I already have hard hat installed. So I'm just gonna say hard hat. You're not inside a hard hat project.
Yeah, go to npx hard hat now.
Relax, okay? Relax. This is the latest version of hard hat.
Okay.
2.0.
Yeah, I haven't played with this one yet.
Yes. Okay. By the way, I'm still trying to figure out why I'm using hard hat and not truffle. Because you told me about a hard hat. Now I'm like, there's a good contender called truffle. Why is everybody using hard hat?
Well, I mean, now it's all not truffle even. Now it's the other one. What's the one again? The one that uses dap tool?
I don't know. Tango? Phantom?
Not Phantom, no. Yeah.
Okay.
I mean, you have to choose one. I mean, at that point, you would be asking, why am I using truffle and not hard hat?
Okay. Hey, it's done.
That's gonna bother me.
Let's move this to the other screen. Okay, so let's see. So it has a contract. Should we do some sanity check to just run this thing, or we assume it works?
Can you explain it?
What?
Can you explain the lock?
Lock? Explain it.
Yeah.
Thing solidity 8.9.
Okay.
Contract call
What does
lock.
it do?
Seems like it has some kind of time. Somebody's an owner. You can specify how long you can lock for. Let's say 30 seconds. Oh, you can put some money in it, and the money is then, I guess, locked. Oh, it sends the money. No, it just sets you up as the owner of it. Oh, so you can lock your own money in it, and then you can withdraw it if that much time has passed. It withdraws.
Got it. Yeah.
Great. Like I want to lock my own money up. Genius. Okay. So let's write our own contract. Okay. What do you want to write? Box? No,
Sure.
I already did box. What do you want to do? It's not important.
Yeah. Just do your name, alphabet.
No, that's real business. Can't do that. Okay, we'll call it music.
Okay.
Okay, first we copy these two lines. Oh, by the way, you know there's a plugin which can add this for you in hard hat if it's missing. That's right.
Yeah. Yeah. I heard of that.
So let's add something called words count. And let's say this is a contract which has music, has a field called words count. So normally you would have a constructor here, and get onion. Okay, why is this complaining? What did I do wrong? What is wrong with this?
You have to do.
Man, that doesn't sound good. What could have I done wrong here? What?
You
Oh,
don't have to do even 256.
Sorry, this.
Oh yeah, constructor
Yeah, yeah.
8.9 and up.
This will all make sense why I made the mistake in a little bit. Okay, so this this code is no good. This is normally good, but from an upgradability perspective, you can't run this code. And the reason is that you can't have constructors because constructors run at deployment time. If it runs at deployment time, it will put this in the words count of music. But we want this code to run through the proxy because the proxy is going to delegate. And the power of delegate is that the code runs in the context of whoever delegated. So you want to run it in the context of the proxy, not in the context of music.
So you have to write a function now.
So we have to make a function, and let's say I call it init, and now it's fine.
Yeah.
Okay, so now the next things we have to do is, remember I was showing you before here on my screen that you must have a bunch of functions for it to be a proxy, like implementation address, update, all that stuff. So for that, if we go here, this is the plugin, not the plugin. It doesn't show it to you here either.
What?
Trying to find documentation.
Oh.
Okay. Well. Okay, so first we have to install this shit. Here it is. Oh, here's a bunch of proxies, by the way, we talked about it. Transparent, UUPS, pure proxy. Proxy follows the 1967 format. You can read about it.
Yeah, that's what I was telling you. Maybe you can explain that later.
Okay, here's the UUPS upgradable. So we need this guy. Oh, here's some bullshit. I don't know why their documentation is pointing here, but to this one, we need to install this package. There's no documentation for it, but go here. This guy, contracts upgradable. So like everything you see on the OpenZeppelin website is also available as, like you can't use it in your upgradable. Running out of time, meeting will end in 10 minutes. Okay. You can't use any of the OpenZeppelin functionality in your contracts because that code is not compatible to be upgraded. So all of the code you write must be upgradable. So that's why OpenZeppelin has another package called Contracts Upgradable, which has all the stuff this guy has, but this time it's all upgradable. So we need to install this OpenZeppelin.
Can you explain this one more time? Why they have it? Sorry, I kind of.
So, for example, you are using ERC20. Oh, they have an example right here, actually. Okay. Let's say you are using ERC721. You can't use ERC721 because ERC721 has a constructor.
So you have to use the US20 upgradable.
You have to use upgradable, and upgradable will have an initialize function. That's one example. Another is that, like, tomorrow, let's say you want to, whatever you are inheriting from wants to update itself, then it takes up more space. It will push all the variables below it further down. So then you will have a clash of where the variables are stored. But the upgradable ones will have dummy variables called gap in them. So it has already like kept space for 50. Then if it adds 5 more, it'll change it from 50 to 45. So then still it's taking total space of 50. So it doesn't push your code down. So like there's certain things in the upgradable contracts done so that in the future they can be upgraded. But the regular
That is the
code,
1967 storage hash you were talking about, the storage thing.
I wasn't talking about that. Okay, let me talk about that.
Okay.
So let's say you have a contract 2, and here we have a variable A.
Yeah.
So then I have contract bar. This has variable B. And let's say B bar extends foo.
Yeah.
So if you look at the memory, at slot number 0, what variable is stored?
A.
And at slot number 1, what is stored? B. Okay. Yeah.
Okay.
Let's say we upgrade this, and the new bar, now there's another one called C. So now if you look at the memory, it's stored like this. But let's say we want to upgrade it, but this time inside foo, we go in and we write a new variable called age.
Now B and age will clash.
Yeah, now we still have A here. What happened is at slot number 1, so in the new implementation, we have A, age, B, and C. But now if you go to read variable B, you are reading the 3rd variable. But, sorry, wait, I'm so confused.
You're gonna get the value of age.
You're gonna get the value of age, yes, because you're reading the second variable.
Yeah.
So like it's all messed up. So wait, why did you ask this question?
You just said like when you do upgradable, like they take care of the storage and they put
Yes.
space
So
there.
what we will do is this guy will say, okay, now what's happening is that A is at slot, let's say 0, then this is at slot 50, and this is 51. So now if I want to add a new one, this makes sense because it basically says that foo takes up 50 spots.
Okay.
So we have 49 blanks, and then A is at the first slot.
49 is just a number they came up with. It's
Yeah,
like no one's gonna add
well,
more.
they came up with a number called 50. So this plus this is 50. So this contract can take up to 50 spots.
Yeah.
So, you know, if we go like this, like 1 to 50 belongs to this guy, then 51st onwards is this guy. So if I want to add a new one, I can go in here, add this, and go like that. So now B is still at 51. Right?
Okay. Yeah.
So now when I read B, I'm actually reading 51, and 51 will still be.
Yeah.
So this pattern allows you to add stuff in the middle without having to like without changing the layout.
Yeah.
So why are we talking about this? You brought it up.
Yeah, you said like the upgradable contract takes care of this. That's why you use upgradable plugin.
Yeah, let's see.
And
Node module.
it takes care of two things, the init, the function init, and
Yeah,
this.
I want to show you some code here. Token, ERC20, presets. So let's see. See, they have this. So they have kept space for 50 to add more later. That's like one thing they've done. The second thing they've done is they have defined initialize.
Yeah, function
constructor.
initialization constructor.
Done that. And all the stuff they are then further inheriting is also upgradable compatible.
Okay.
And another thing, which they have done is that it's right here. So like in constructors in Solidity, when you call a constructor, it automatically calls the parent constructor.
Yeah.
It automatically calls a parent constructor. And if you have multiple inheritance, you are inheriting from two guys, and they both inherit the same one guy on top. So that one guy on top will get called only once, not twice. That's some kind of magic Solidity does for us. But because we went from constructors to regular functions, now it's our responsibility to make sure that happens. So they have also done some work to allow you to do that. So they have like two versions. So here's the initializer, and then which is basically calling the init function. But then they have init and init unchained. What init does is it calls itself and then all the inits of its parents. So this guy's parent is ERC20, is calling that guy, and it's calling its parent. And unchained will just call its own init stuff, nothing on the parent. So it's giving you that flexibility, saying like, hey, you decide how much stuff you want to init. Because if you are inheriting from somebody else and that guy also inherits from ERC20, then you don't want to call this guy, because then both of them will call ERC20 init. It'll get called twice. You may not want to do that. So that's another thing they're doing. And they're also doing this stuff, and I'll talk about this in a second. So this upgradable stuff is what you want to use. You don't want to use regular package because they're doing a lot of stuff here.
Got it.
Okay, we had a 40-minute session. There's like 1 minute left now. And then we're gonna wrap this up. So
we can wait, and we can wait for 5 minutes and do another one. 40 minutes.
Yeah, and then I'll have to go. Okay, so let's deploy this.
Okay.
Oh, no, we have to first import
the upgradable thing.
Not this guy. Proxy. This guy. Oh, I spelled that wrong. Proxy, utils, UUPS. Okay, upgradable. What's wrong?
Contracts, upgradable.
Nothing ever works, man. It's useless.
Do you have to do .sol? That's why.
I don't know. I am okay. I don't know what's going on. Oh, this is the problem here. That's one. No. Why? Why the fuck do it not work? Go work, motherfucker.
It's being recorded.
Oh, this is supposed to work. Did I not install the package? Let me see.
You did not install the package.
I did install it. We actually saw the code from here too. It's here. This is just unacceptable. Okay, whatever. It's supposed to work. And it's working. Let's compile it. Could not find this. Upgradable contracts. Why would it not work?
Do dot so see if that makes a difference. I don't think it does.
No, that was it. Okay, thank you.
Oh, that was it.
Okay, so by inheriting from UUPS upgradable, we have gotten this stuff. This upgrade to function, which allows you to add a new implementation address, kind of like I showed you in the beginning, and it checks its authorized function, and it defines that as an abstract, like it doesn't have any implementation. So it's our job to include this function and check that, hey, are you authorized to upgrade or not? Right. So right now, if I compile this, it should fail saying, hey, you haven't defined this method.
Okay.
Okay. It's saying something function. Oh, that's fine. That's this problem. Okay. Second is saying, hey, this thing is abstract. You need to define this thing. Yeah, let's compile it. Okay. So do you follow what this code does?
This is authorizing this to be upgradable. I'm not exactly following exactly what it does.
Okay. So this contract is now upgradable.
Yeah. Got that.
And this function controls who can upgrade it. And right now, it doesn't throw any error. So anybody can upgrade this contract.
Right.
Normally it would be like if, or we can say like require message.sender is equal to
Owner or whatever. Yeah.
something like that, or you are bad. Like this. Now this would only allow this guy to upgrade.
Got
But
it.
leaving that complexity out, I just want to launch a upgradable contract with you before we run out of time. So
Yeah.
this is now upgradable. So let's try to deploy it.
Yeah.
Or should we write a test? Both options are for you. Whatever you want to see. You want to see a test, or you want to see
whatever you think you can accomplish in the time.
they're both same amount of time, dude.
Okay, then there are tests.
Test. Okay. Music test. JS. Okay. So let's see here. Copy this stuff here. Okay, so we're going to use chai, hard hat, some constants, scribe, music, spellings. Okay, so function, not function. This is the first test that we can actually deploy this shit.
Yeah.
Okay, the keen person, you have noticed that hard hat, something called upgrades is being imported. This is not normal hard hat, so let me just show you what this is. Okay, let's run this.
Upgrades is undefined.
Let's get rid of this lock shit.
Yeah.
Let's delete the lock file. I don't
Yeah.
even want to see. I don't want to see it.
Yeah,
Real estate. Okay. Oh, upgrades is undefined. Did we not install this plugin? We need to install this plugin.
HH upgrades.
Did we installed this? This is the contracts, but to upgrade it, we're going to use this plugin by Hardhat. this plugin, and it's this guy. Copy this. We don't need ethers. We don't need this. Yep, this is it. So what this does is it gives us the functions to actually do the upgrades. And the point of this functions is that it will do all the checks. So if you mess up, it'll be like, hey, don't upgrade. Now if I run my test, why is it still undefined?
But you still did the Open Zeppelin though. I think it's harder.
No. We didn't require it.
I see.
This line. Yeah, only if you follow the instructions, if you know what to do. There we go. Hey. So you can see upgrades has some stuff in it. And here are the two functions we care about: deploy proxy and upgrade proxy. So music is equal to ethers.get contract factory, and name of the contract is music. So normally you will get the factory and you will do music.deploy, and this will deploy the music, right? This will give you an instance of the music contract. This much you know?
Yes.
Yeah, you know, or should I? You don't seem very confident, so I'm just gonna like show you this.
Oh boy. P1.
P1?
Yeah.
Oh, what the fuck? Awaited. You know, I feel like await should just be defaulted. Everything we're awaiting on, so why do we have to manually write it? Hey, okay. So you can see that it deployed them. I see you're busy with the
One
P1?
second. I'm gonna say give me.
You really have a production P1 right now?
Well, yeah. Jody just raised it.
You know this call is being recorded, right?
Yeah. Whatever.
You don't want to take
You
any
can-
names.
You can cut it out.
You want me to sit and edit this shit? I'm not gonna do that.
Okay.
This thing's going on your Discord channel.
I'll
Okay.
cut it.
Okay. Now that I have your attention. So this is how you normally deploy a contract, right? You get the factory and you call deploy on it. But we're not going to do this. We're instead going to do upgrades.deploy proxy. Now, first thing it wants is a factory, so that's music. And then it wants any arguments. It's going to pass those arguments to the initialize function. So we're just going to give it a word count of 100. And options. And in options, we're just going to say kind UUPS. Now, just so you know, like I'm not, you know, regurgitating. I am not regurgitating this from memory. These things are right here. Look at deploy proxy.
Yeah.
What contract you want to deploy, what arguments you want to pass, options, initializer that defaults to, yeah, let's write this too. Like, what's the name of our initializer? It is init. So instead of instructor, it's calling this guy.
Yeah.
Here are the arguments. Unsafe, no. Kind is UUPS. Okay. And this, my friend, will give us in music. Now this is going to be the proxy version of the contract. Failed. Oh, didn't await. Yeah. Okay. And so it can be deployed. Next test. What do you want me to test? It has some word count. Has words count. So let's move this to a before, or do you want me to redeploy it?
Don't worry about it. Just
Spelled async wrong. Music dot words count. This to be equal to 1000. Oh, it's wrong. Oh yeah. Let's put parentheses. Okay. Oh, it's still wrong. 100 is not equal to 1000. Why? Oh, because you put 100 here. Okay, definitely working. This means. Okay, cool.
can I
So
look
we
at
can,
the test one more time?
yes, we tested that we can deploy it. Then we tested that it has indeed a property called words count.
Okay.
And we also printed the address.
Yeah.
Okay. Let's now upgrade the contract to have another field, but we want to still preserve the old information and we want to preserve the address, right? Those are the two benefits of a proxy.
Yeah.
You still get to keep the old address and old data.
Yeah.
Okay, before we go there, actually, there's one problem here. This function initialize, which we wrote instead of the constructor, anybody can call this function. So anybody can come in and call init 20 days later, and it will reset the words count.
Yeah.
What we want is this function should be called only one time when we are deploying it.
Okay.
So there is the Open Zeppelin kind of like gives us this stuff here. So it has given us a. I'm going to find documentation for you. Show you here, initialize it. So it has this thing which has some kind of code. Let me show you the code. Why is it not? Oh yeah, this is why. So this is strange that like their code just like this should be contracts dash upgradable, but it's like I don't know why they're okay. So the modifier, so they have this variable called initializing, initialized, event, there's a modifier initializer, and basically if I write this, then it can be only called one time for that version. Okay. So if I go here and I put this here, this will make sure that it can get called only one time.
Okay.
My test should still pass. Okay, cool. Let's write the next version. Okay, so one of the things when you're writing upgradable contracts is you don't want to change the layout for the variables. So what I like to do is I basically just copy the exact same file over, and I'm going to call this version 2. And because I copied over, I preserved everything it had, and now I'm going to add something new to it. I'm going to call it public. We had words count, and we're going to call it phrases count. Okay. So we've added something else.
Yeah.
And let's try to, this is the new version. So the new version should still have the old words count, but it has something new called phrases count, and it should default to obviously 0 because we haven't put any value in it. So let's see if we can do that. Let's go here. Just write version 2 of the tests. Okay, I want you to tell me what to do now. What do you want to do? What should this?
I just want to test that phrases now exist.
Well, we have to first see can we upgrade it or not.
Okay.
So you don't need this console.log anymore. I'm going to remove this. So now we're trying to deploy what?
Music v2.
My music. This is version 1. We deployed version 1. Now we're gonna get version 2, which is this file. Music 2. Why is this a red squiggly line here, by the way? It's not nice. Why is it red
Because
squiggly?
you're using it music,
Where?
const music again. No.
Oh yeah, that's why. Okay, this is music 2, of course. Okay, so then we're not gonna, this is gonna be an upgrade. So now we're gonna say music 2.
Upgrade proxy, right?
Yes. Upgrade proxy. So now it needs the old proxy address. So that's this guy.
And then you'll pass it 2 arguments.
Yes, music 2. Factory. And let me see if I want to give you any options. Let's look at the code here. Plugins. Okay. Proxy address, new stuff, and some options. We don't need any of these. Okay. So now if I do console log music2.address, and here I had music. I should have just copied this line, right? This address and this address should be the same. That's the test. You can say expect music.address to be equal to music.address. Okay. Test it. Hey, you can see that music and music 2 both have the same address.
Yeah.
And let's just write here, continue writing this test. Music 2 dot phrases count. Await. Expect to be equal to 0. Yes.
Yeah, because that's
This
we haven't
will-
passed anything.
this will prove that it has been upgraded, right? There
Yeah.
we go. It passed, then fail. And here's like the other reason why we upgrade. The old data is still there, right?
And what count is still 100.
Test. So we still have the same address, 0f7. It has the old data and it has the new data. We have upgraded the proxy.
That's cool.
Well,
All right. Oh, stop recording.
You want me to deploy this in production to Rinkabay or something, or I can show you some more advanced. Says this is very basic, so like some more real things of proxies, or you have a P1 you want to focus on. That's fine too. P1, okay.
I have to say something. I can come back in it, but I have to put some water on the fire now.
No, I think this is a good place to wrap it up, and then we can talk about it. Sure.
Yeah.
Fine.